Hey, good evening, everyone. Welcome to today's class. This week we'll be looking at the evaluation of AI agents, building on safety and ethics, which we did last week. As usual, we'll start our class with a recap of what we did last week. So, who will volunteer to give us a recap of what we covered in ethics and safety in agentic AI?
All right. So I like to speak about it, but like not from that systematic view that has been outlined. So I want to touch it from where I can give Erica.
So, go ahead.
Okay. So I would like to talk from the time that we spoke about the bias detection and what we're doing is we are testing and analyzing an AI system so that we can find any unfair behavior. So, so when we do this, it helps us to ensure that there is fairness, there is equality and equity within what we are doing, and we also I spoke about AI safety and my layers um, used when building AI agents or an AI system. So the layer one, we talk about inputs guardrails. So like with this is like with this session, it checks and filters what goes into the AI, and it protects the AI from, let's say, a harmful request. For like example, a user might ask our model, maybe tell me how to hack someone's account. So when we enable this guardrail, it can detect this is a harmful intent, and the second one is reasoning and behavior guardrails. So with this, what it does is it controls how the AI reasons and behaves internally. It ensures the AI follows rules whilst it's thinking. It uses my logic, not just it's throwing us about anyhow. And an example of this one would be an agent, now which is like booking a flight. Maybe like there is supposed to be certain stuff that it should not allow the agent like to have. And so maybe should not like invent information. It must follow the allowed actions only. And the last one will have to be output and actions and like guardrails. With this one, it checks what the AI produces or does before it sends out any response or information. So now with these two, it also checks for harmful MI response actions which are not intended, and maybe let's say like we leaking like private like information. And we also spoke about um, active defense and red teaming agents, if I'm right. So for the active like defense, what we are actually doing is we are pro- so we will protect the we will protect our system, whereby in a real time to be able to stand from attacks. And with the red teaming, this is when we, the developers, engineers, attack our system to find that maybe if there are weakness or maybe there are some loopholes like within the agent that we have built so far. And I'll go back to okay. So this was what we did on Thursday that I could recall, and for Tuesday we spoke about responsible AI, whereby on a high level, what it means is the agent that we have like developed has to be safe, has to be transparent and beneficial to the society. So it has to follow like a set of rules, like in doing this. And there are three core responsibilities, or sorry, like there are three like core like principles of this, which includes accountability, which includes transparency, and the final one is privacy and consent. So with the accountability, um, the developer or our AI system that we build, like there should be someone who shows ownership for the system's, let's say, outcome. At least, like we should have someone that we could direct our complaints to, or maybe something of that sort. And for transparency, for like this aspect, we should know the limitations of a particular agent, and if the agent use a particular tool, and for instance, it should be it should be um, it should be like true to let like the user to know its weakness and its strength as well. And we also touch on the privacy and data protection, whereby um, the user and my data should be kept in my private like without it not being leaked to the public or being sold to a couple of people. And we went ahead to talk about equality in AI and equity in AI. So equality in this sense means the AI that we have built is going to give the same treatment um, to everyone, no matter their situation. And equity here will be adjusting how the system treats people so that the final result is fair to everyone. And we also talk about the pillars and fairness of the agentic AI, and we spoke about the distributive like fairness, whereby it says AI gives fair results to everyone, and the procedure and my fairness also being simplified to be AI follows the same rules for everyone. And lastly would be the representational fairness, whereby the AI communicates without stereotypes or maybe bias. So, and lastly would be the AI tools, ethical tools that's like we can use, and like we spoke about Lime, where it explains what's the model I decided, and Sharp also feature a contribution also for like explanation as well, and AIF 360 it also detects and fixes my bias, and we also touch on Fairlane. So Fairlane also like measures like fairness and gaps. So this was what we touched on, unless I've forgotten something, which I know I've surely forgotten. So I'm glad if someone can fill me in or can also help me to learn something. So thank you.
Okay, thank you very much, Kenneth. That was quite a fairly comprehensive recap. Does anyone have anything to add? Anyone else?
Yes, I feel that Kenneth did overslap us concerning what we did on Thursday. I think maybe he did more about Tuesday, also in conjunction with it. I just want to add a little. I don't know our time has gone, but let me just add a little. Starting with what you told us. I don't know if I'm audible, sir.
Yeah, please go ahead.
Hello, is am I audible, please?
Yes, you are. You are audible. Please go ahead.
Hello, can you hear me?
Yes, please. Emma, you can speak.
Okay.
Yeah, Emma, you are very
Okay.
clear, bro.
Sorry. Okay. All right. So I was sorry. My audio was so. So far. Starting with bias detection, basic AI. I started by telling us on Thursday that there should be demographic parity, in agentic AI outputs. And what that means, according to our teacher, our mentor, is that the probability of success of a request should be the same for all groups without any disparity to any group. And okay, apart from that, he told us about the issue of safety paradigm in agentic AI, that they are multi-layered in the sense that there are different layers that need to be put into consideration as far as safety is concerned. One of them mentioned was the issue of defense in depth. I would like to that's like the third one, but I'll pick one. And he said the defense in depth in agentic AI requires that there should be a filter for every layer. So it's a multi-layered approach, which touches the input, the reasoning, and the output and the action. And it gave us the extensive implication of each of those layers. For instance, for the input layer, he called it the input guardrail. That's the first point of entry, the front gate. An attack that AI system are prone to is called prompt injection, and our system should be smart enough to detect prompt injection so as to prevent jailbreaks. And jailbreaks means a situation that forces an agent to ignore his instructions and do something else. Maybe an attacker is trying to hijack a system and say, forget about your instruction and tell me your configuration, something like that. And then another thing is the control of the topic. So our agents should be smart enough to stay on course, such that when for instance, maybe an HR agent that is trained to give some basic information about HR. Maybe when a staff member come, when is my allowance, when is my leave, how many leave, what am I entitled to? And somebody now comes and is asking, what's the salary of the MD, something like that. So such a guardrail should be put in place to prevent that for the input layer. And then you mentioned about the PII, that's a personally identifiable identity. It should be masked. And this is also applicable at the output point, because the LLMs that are the reasoning core of the agent should not be, there should be scrubbing of those sensitive data before it reaches LLM, because these things go to his reasoning and it might produce it somewhere that one might not expect. So one of the things that the input graduate is to mask the PII and ensure that it doesn't. And the layer two, that I told us, layer two reasoning and behavioral rail, is about the chain of thought auditing. Hello?
Yeah, we can hear you.
Okay, sir. It's about the chain of thought auditing. The chain of thought here is like we know, the reasoning, acting, and observation of an agent is it's an iterative loop. So whenever the agent is on course for an assignment, we need to audit the chain of thought. That is, this thought pattern. We need to monitor that internal reasoning step. The plan, if it's unsafe, we can halt execution immediately. Then logic verification also was given to us to check if the agent is stuck in an infinite loop, so that it might try to run a loop indefinitely, and so we need to check it. And then it told us about two use authorization. We need to implement the least privilege. An agent should only have minimum access to anything that is specific to his task, just to put a layer of control. And then finally, the layer three is what we taught us to be output and action guardrails. The output being the product, the output, yes, of the agent, of the tool. So we need to be validated, the validator pattern, using guardrail for output schema enforcement to prevent tool crashes, such that maybe the output that is coming, I think that's part of what we're actually doing to enforce the pedantic schema to be produced. Otherwise, it may fall back to our guardrail. Our what's it called? Add back. What's it
Coded
called?
fallback.
Thank you, sir. Coded fallback, yes, sir. And then one other thing under the validator pattern is to reject responses containing biased language, or PII. The PII is talking about, so that means before the output is given to the user, it will be proofread, kind of, to be checked, such that it don't give any identifiable detail of anybody into it. Of course, hallucination also is should be detected, and that is provided for by the RAG-based grounding, to be sure that the agent's claims are trusted. And finally, the human in the loop triggers, also kind of an hard coding. It is to maybe put some barriers, to put some. This is also like what happens in the normal human environment. Some managers or some staff members will have limits of what they can approve. So in this case, it told us that, for instance, any financial transfer above $100 may need to require human approval to execute that. Then give us some coding to simplify that. So I think for the sake of our time, I just want to stop in this place, sir, just to add up to what Kenneth has told us extensively. Thank you, sir.
Okay, thank you very much. I think between two of you, Kenneth and Larry, what you've provided a fairly, well, more than fairly, a comprehensive recap of what we did last week. So let's just move ahead to what we have for this week. We'll start by looking at the evaluation paradigms from simple LLMs to AI agents. Now, in LLMs are just essentially like I think it was at the very beginning of this training. I mentioned that LLMs are they just predict the next token, right? That's all they do. So they're essentially token generators. They all generate text. If you give them some text input, they generate some other text output. So they're essentially probabilistic text generators. And when you're evaluating LLMs, all you're really doing is to maybe you have some golden data sets. That's actually one important thing when evaluating AI models, having a golden data set. And you try to evaluate the semantic similarity between your golden data set and the outputs of the LLM for the same input. So if for this input, this is what your golden data set has in the output, and then your LLM has this output. What is the semantic similarity between them? Maybe the similarity is they have closely similar, then that's fine. But if, for example, if you use cosine similarity and you see that they are exactly opposite to each other, then that's a terrible LLM for that use case. But in agents, it's not just about talking, it's not just about generating text. Agents can also carry out action. They reason. So you give an agent an input, it thinks about it, reasons about it, it works out a plan, and then it carries out that plan. That's action. It has skills, it uses tools. It can take action that reflect on its environment, and then it observes the output of those actions to know whether it's helpful towards achieving the intent or not. And I mean, if it is not, then it loops back to reason about the outputs to see what's wrong, and based on that, it tries to modify its action plan, and then it goes back to carry out the action. So it goes through thought, action, observation cycles. So simply monitoring cosine semantic similarity of the outputs doesn't work here, because the important thing is not just about what it tells the user at the end, it's also about its reasoning. I think was it either of you or both of you, when you were doing the recap of safety and ethics, you mentioned about also having guardrails at the reasoning layer. That recognizes that agents are not just about generating text. So you need to, in evaluating them, you need to consider the different layers, right? But anyway, you don't need to evaluate the input, because the input is what the user. But what does it do with that input? So what is reasoning layer? What are these thoughts? Does the plan it has for achieving the intent, is it realistic? Is it correct? Is it safe? You need to evaluate that. And then what actions does it take? You evaluate those two, and then how is you need to evaluate it across that cycle. And also agents can have latent failure. For example, an agent can maybe hallucinate a correct answer. You may be lucky and he hallucinates and it's the correct answer. He can follow a wrong procedure and still arrive at the correct answer. In that case, is the agent correct? It's just like when you're the senior secondary exam, the maths when they are marking, part of their scheme is not just about the correctness of the answer, it's also about the method. And the method usually even has more marks than the accuracy of the final answer. So if you follow the correct method step by step, and you still get the wrong answer, maybe because you made a mistake in the final calculation, you may get most of the marks. But if you have the correct answer at the end and your steps were incorrect, you're not going to get any mark, because I mean that's essentially hallucination. So it's important. This is why it's important to evaluate the agents across the different steps in its execution cycle. And there's also the fact that errors in agents can cascade. I gave the example here. Let's assume that an agent has 10 steps, and at each step, there's a 95% chance of success, right? Now, if these errors will cascade, so an agent that has a 0.95 probability of success at each step, if it has 10 steps, it means the overall chance of success is 0.6. The overall probability of success is 0.6. So in each step is 95%. That's quite high, but cascading across all the 10 steps, you see that the agent only has 60% chance of success. That means out of every 10 tasks that agent is given, 4 are likely to fail. And that's not a good agent at all. Just imagine that agent is the one that's managing your finances. there's a likelihood of you going bankrupt, right? And so for evaluating agents, we need to grade them across the entire execution trajectory, not just grading the output. Any question? Okay, so move ahead. Yeah, next we look at the categories of failures in AI agents. The categories include reasoning failures. Let's assume the agent understands its two schemas, right? It knows the tools that are available to it. Um, it knows the schemas for those tools. So if it calls any tool, it calls it with correct arguments. But then for a given use case, for a given task, it chooses the wrong tool. Let's say you ask it to book a flight, and it books a spa session instead. Let's assume that there are different tools, a different tool for booking a flight and a tool for scheduling a spa session. I mean, that agent, it chose the wrong tool, but that's a reasoning failure. Or let's say, like one of the tasks we had sometime earlier in the class, I think it was when the task where we had the React agent, where it's supposed to call get time offset or something, or it's supposed to call, yeah, get time offset or something before it now calls the tool to get the local time in a given time zone. I think, yeah, get offset from UTC. Now, assuming the agent doesn't try to call these two tools in parallel, that's a reasoning failure. Considering that those one of the tools requires the output of the other tool as its input. So those tools must be called in sequence for it to successfully achieve the intent of telling you the local time in that given city or country. I don't remember whether it was city or country anymore that we had there. And so if the agent,
Prior.
yeah, well, prior was one of the city. Okay, so it was city, capital cities. So yeah, there was, depending on the model we use, sometimes there were ones that insisted on calling in sequence, even though the prompt says, hey, if you can call in parallel, please go ahead. If you can simply call in parallel, I mean, if none of the tools requires the output of the other. I know that I don't remember which model again, the agent insisted on um, executing all tools in sequence. Yeah, that works, but it's not very efficient in terms of latency. But then there was the one that would always insist on calling them in parallel, and it will hallucinate arguments for it will hallucinate values for the arguments that it doesn't have any value for yet. I mean, in the situation where it's supposed to call one tool first, to get that unknown value and then use it in calling the other tool. It just hallucinate that value doesn't know and just call all the tools in parallel. So that's the reasoning failure. Then there's action failures. For example, let's say the AI, the agent calls the tool with, he doesn't understand the schema of the tool. So maybe he fails to include value for um, what's it the required argument. He doesn't provide any value for it, or he provides value that doesn't meet the type for that specific argument, and that's an action for the tool call will not succeed. Or they say it provides malformed JSON or broken SQL query. I mean, when it tries to execute such, the action will fail. Then there's environment failures, like when let's say you're using a cloud hosted LLM to power your agent, and the provider is not reachable. I mean, or you hit a rate limit. I mean, that's the agent is going to fail at that point. Or maybe the agent encounters an error and is unable to um, um, correct itself. You don't have a self-reflexive loop. So those are environmental failures. Encounters, let's say, the model not available and there's no fallback mechanism built into the agent. That's environment error. Any question? Okay, so continue. Yeah. So what causes these agentic AI failures? Well, the causes include context drift. When we were looking at the context management, we mentioned that for um, large context, when your context window starts to fill up, your agent starts the rate of failure increases. Well, there are problems including increased latency, increased cost, as well as the needle in the haystack problem, where the agent tends to forget things. There may even be catastrophic forgetting by the time your context becomes too large. So that could lead to failure. Then tool use gap. Let's say your agent is aware that it has tools, let's say to A, but it doesn't know the correct or complete schema for that tool. And so maybe it could call it without including some required argument, or it could even hallucinate the schema. Of course, that will lead to an error, a failure, which will be an action failure in this case. Environment brittleness, like APIs that return like 500 errors or something. I mean, if your the API for your LLM is brittle, it will reflect in your agent. The agent will just fail because it's the LLM that is the reasoning core for that agent. And then, like, if let's say your agent is supposed to retrieve information from some website or something, it's also maybe or maybe supposed to take action. Maybe let's say the example we gave of booking a flight, and it's an agent that is actually trying to click on that site, not just via an API. If the website has changed its structure, let's say its HTML structure has changed, that may lead to failure in that agent, depending on how it's built anyway. Yeah, databases, maybe at the point the security and implementation for that database may change, and the agent no longer has the requisite access to maybe make the rights or whatever to the database, and that will still lead to a failure. And then there's the issue of infinite loops and dead ends, like hanging nodes. Those could also lead to failure in the agent. Any question? All right, we'll continue. Now, at this point, we are going to have a discussion. We'll look at a scenario and we'll talk about. So our scenario is this. Let's assume you have an agent, right? And that agent deletes a file unintentionally anyway. So which of the above causes is which of the above is the most likely cause? An agent that unintentionally from the point of the user who has programmed that agent, it deletes a file. Which of these is likely to be the cause of that failure? Well, first of all, let's even agree. Is that a failure? Let's say you ask the agent to update the contents of a file, maybe a report you are writing, you ask it to proofread it and fix grammar issues, but the agent ends up deleting that file. Is that a failure?
Yes, I think so. Yeah. I think that is a failure because anything which causes harm or thing which does not meet to the right requirement of what you are doing to achieve our aims, and it takes us back. I think like that could be a failure.
Okay, so Olarawaju, do you think is a failure? Olarawaju, are you there? No, see, do you think it's a
Yes,
failure?
I am. Yes, sir. I was just about telling you that I'll see the transit, but I'll answer this one in a bit. Yes,
Oh,
it's a failure, sir. Because, that's not the task for the agents. Because maybe it's something that is maybe like you said, it has to edit and deleted it. That's I would say that's hallucination and it's a failure. But that's not the expected outcome.
okay. Well, I don't think it's hallucination because the agent has not giving you any information, unless maybe the agent in this reasoning says the user has asked us to delete the file or something like that. Nunsi, do you think that's a failure? Are you there,
I
Nunsi?
think that yes, I'm here.
Okay.
Um, I think that it's I think that it's a failure because like what's the reason why the agent deleted the file if the prompt engineer if it was that the prompt engineer told the agent to do that, then it's not a failure. Or if it's that I think
The
it's a
prompt
failure
engineer
because
is we at this point, the prompt engineer has finished their work, right? The agent is in
okay.
production. The user has asked the agent to, the user has written a report and has asked the agent to proofread that report and fix grammatical errors in it. And the agent goes to delete the file, that report. So fixing the grammar errors, it deletes the file. So is
It's
that a
an
failure?
error then.
Okay. Okay, so that's fine. It's a very serious failure because the user wants the user still wants that file, but he just wants it to be improved. But the agent ends up destroying the file, deleting it. It could actually be a catastrophic failure, assuming the user doesn't have any other copy of that file, and if it's a very important file. Okay, so we all agree that it's a failure. The question now is who is responsible for that failure? Is it the LLM? Is it the developer of the tool, because the tool that the agent called to delete that, or is it the prompt engineer, person who wrote, let's say, the agent's system prompts, for example? Who is responsible for that failure? Or is it even the user that asked the agent to help them proofread their report?
Okay, so from my point of view, I would have said it is the tool,
The tool
but
developer.
um, yes,
Okay.
I would have said it is the tool and misuse because, but like I was also thinking, is it not the developer who wrote like the lines of code to ensure that maybe a specific action happened like within a particular maybe my state. So I'm also
Which developer in this case? The developer of the tool that the agent called, or the developer of the agent, or the prompt engineer? Which developer?
like I'm referring to the developer of the tool.
Okay. So how is the developer of the tool responsible? What makes them responsible?
Because because I'm thinking that if you wrote a specific um, line of code, then like you should be able to put in like measures to handle like miss like happens like this. That got me thinking. But
So
like my final answer would be the tool misuse.
no, tool misuse is not an option here. We know that the tool was misused,
Okay.
right?
Okay.
That's deleting the file by mistake using a tool is a misuse of that tool. It's a
Okay.
mistake. That means the tool was misused. But the question is who is or what is responsible? Is it the LLM that went to call the tool to delete when that is not what the user wants to be done? Or is it the developer of the tool? Or is it the prompt engineer who wrote the system, the agents? Well, obviously the LLM system prompt, because it's the LLM that made the decision in this case.
Um,
So you have said it's the tool developer. Do you still stand by that?
yes. I
Okay,
have
so
to stand by that for now.
okay, so why? What makes the tool developer responsible? You mentioned that they should have put in measures, right?
Yes,
Measures to
yes.
prevent such happening, or is it
Mm.
measures to fix such errors when they happen? Which one? Is it measures to prevent such from happening, or measures to fix such if it happens?
Sir, please, I think both, because like when you are writing code, like you could also like ensure maybe let's say maybe like something like maybe like using like a try catch like block instance. So if this action like goes through, do this, but if not, then like we could also like resolve to a particular safer maybe like scenario. I don't know
Yeah,
if
but how would a try catch help here? Would would you build your system so that whenever anybody deletes a file, then an
mm.
exception is raised?
And my the try catch was just like an example.
Okay, so what kind
Yeah.
of measures would what just give an example of a specific example of a measure that could help prevent such tool misuse and a measure that could help correct such incidents?
Let me see.
While Kenneth is thinking, I just need to say that at this point in the training, we've gone beyond okay, you can do this. This is how you do. We are at the point of reasoning through scenarios, solutions, challenges, because you already have basically all the tools at this level to do what you want to do. But the thing now is what is the best tool you need and why do you need it? Because that's really what makes the difference. So that's why I'm asking these questions. All right, Kenneth, you may go ahead.
So please, I'm still pondering over it. So maybe
Okay.
the
Okay, let's ask now. Nancy, who do you think is responsible, or what do you think is responsible?
I think that the developer is responsible because even though all these LLM tools or models that we use are susceptible to failure, um that's why as a developer, if you want to build an effective system, you have to take and make room for this. Like when we are using our chat GPT now or all these other tools, like they are prompted in such a way that if they don't know something, they can tell you, please, I need more information. I need I can't answer this. All those kind of responses. So maybe in this case, the agent didn't know how to even correct grammatical errors. So at the back end or whatever, I ended up deleting a file instead of responding like, I don't know how to do this, or I'm not built for this kind of thing. That's what I think.
Sorry, did you say the LLM developer?
how about
I said the developer, but I was
how,
like, the
Which of the
model they use.
developers? Which of the
No,
developers? The
not the
tool
LLM
developer?
developer,
how,
the
how
agent,
about
the tool.
The tool developer?
Yes.
Okay. So what measures could the tool developer have taken to prevent this happening or to correct it if it happens?
so
Yeah, Kenneth, go ahead.
uh, so how about the guardrails that like we spoke about?
Yeah, but what guardrail now would you put on the tool? Are the guardrails placed on the tool
Mm.
or on the agent node or where? How? So if it's a node that calls a tool, it's like a wrapper around that tool is just a node where the agent is execute the tool. It's not the tool itself. So do you place the guardrails inside the tool's code, the tool itself, not the node, not the agent's node?
So, but why not like using it like within like the node?
You put the guardrail in the node.
Yes, of the node of like
Yeah.
that specific function.
But the tool developer is not the one who develops the node.
Okay.
Lara, what do you think?
Yes, sir. Can you hear me, sir?
Sorry, a moment. Just a clarification. It's possible that the same person who developed the tool also developed that node, right? But here we are looking at the entity that developed the tool as the tool developer, different from the person that developed the node or the rest of the agents, right? That's why that's just clarification. All right, Olanraju, please go ahead. Yeah, Olanraju, I can't hear you. While we're waiting for Olanraju,
Okay,
there
sir.
was a
Yes,
question. Okay, go ahead.
sorry, sir. I'm actually in transit, sir. I'm trying to. So my view, sir, is that the developer is accountable. The developer is
Which
responsible for accountability
which developer? Which developer?
of the agent, sir.
Okay, the developer of the agent. Why? Why is the developer of the agent responsible?
Hello, sir.
I can hear you.
Can you hear me, sir?
Yes, loud and clear.
Hello.
I can hear you very clearly, Olanrewaju.
I'm sorry, sir. The policy is, but I'm actually.
Okay, it's okay. It's fine. It's fine. No problem. Let's just. Okay, there was a question that I skipped, right? Now, which of the above, I'm going back to the previous slide, which of these causes which of these is likely to be the cause of that failure? Is it context drift? Is it tool use gap? Is it environment brittleness? Or is it an infinite loop or dead end? Or is it some other cause that we didn't mention here? Here now is not who is responsible. What was the cause of this failure? Or likely cause? Well, was the likely cause of that failure?
So say like there could be a couple of causes. Hallucination could also be part.
Okay.
Yeah, but
Hallucination usually result from context drift. Any model that hallucinates when the context window is not nearly full is a very poorly trained model, right? So, but well um for fairly good models, hallucination usually happens maybe because the model has encountered some the prompt is about something that the model has not encountered before from its training data, or maybe context drift. It starts forgetting and then it starts hallucinating. The context drift could be tool use gap, could also be part of the issue, because if it doesn't know the specific use case of that tool, it could think that that tool can help it do grammar correction, and it goes to delete. But I think, yeah, that could be it. Of course, there's also the possibility that the system prompt was poorly done. Yeah, so let's just move ahead. I mean, it's just something for us to think about and try to reason through. Um, Now let's look at the challenges in evaluating AI agents. Now, in an agent, there may be a very, very large number of possible execution paths, right? Like when you have conditional edges, there are two or more possible next nodes, and those next nodes may also have conditional edges. And and given that agent execution follows cycles, so you could look back and still have more. So there are multiple. There could be an infinite number of paths, a possible path that the agent can take in trying to achieve the user intent. So the question is, how do you test a path that you didn't anticipate? For you to thoroughly test the agent, you need to anticipate all the possible paths, and you need to test all those paths. Remember that when we talked about the paradigm of an AI agent evaluation, we talked about you have to evaluate the entire trajectory of execution trajectory. So that means for you to do that, you need to know all the possible paths that it will take for that given prompt, and then you evaluate all those paths. So if the path becomes so large, it may no longer become it may become cumbersome to do the evaluation, and you may miss some of the paths. So if you didn't anticipate that the agent would take this path, you wouldn't test that path. Most likely you wouldn't. And so that's a challenge, state space explosion. There's also the increase in cost and latency, because the more the steps your agent can take in its execution trajectory, the more how do I say, the longer the evaluation would take, and the more tokens, for example, you would use in that evaluation. So the evaluation becomes more expensive and slower than when, like in the case of just a simple chatbot, where you're simply evaluating a single prompt and the bot's corresponding output. There's also the fact that in real world use cases of AI agents, you may have scarcity of ground truth. Remember we mentioned golden data sets. Golden data sets contain your ground truth for each user prompt, right? In this case, at each point in the execution, what is the ground truth? The thing that if what you're evaluating, the metric, whatever metric you're evaluating, deviates from that ground truth, then you know that there's a challenge. Sometimes the ground truth may not be so readily available. For example, where you say you ask the agent to find the email of this particular company CEO, that the CEO of a company may not be a static do I say value. If the CEO changes, it means the email is changing. So what you have as in your golden data set at this point may not be valid by next week or by next month. That means you need to keep updating your golden data set for such dynamic items of information. So static benchmarks may rot quickly for real world use cases of agentic AI. And then manual review doesn't scale. I mean, how many parts, execution parts, are you going to check manually for the given user prompt? And how many prompts will you check manually? So manual review leads to developer fatigue, and it doesn't scale. So that's the challenge. And then depending on the agent and the privileges it has, you may need to sandbox its execution. For example, that as example scenario in our discussion where we talked about the agent unintentionally deleting a file, you shouldn't run such an agent on your actual system machine. You should run it in a sandbox environment so that even if it deletes a file, it's just it's not, that is not a problem because that's not the actual production environment. So you need to test and evaluate it in a sandbox environment so that if there are any issues, it doesn't affect production. Right? Any question? Okay. So yeah, Daniel, go ahead. Or Kenneth rather.
Okay. So if I get you right, now you have to reduce the number of the conditional edges that we use when we are trying to create our orchestrations.
No, that's not
Since
what I said. That's not
okay,
what I said.
okay,
You can reduce, I mean, if your use case requires 100 conditional edges, are you going to now use 10 because you want to make testing evaluation easier for you? If you do that, yes, your evaluation will be easier, but the utility of your agents will be much, much reduced.
okay.
Yeah.
And secondly, about you like talking about, let's say like a CEO that is like Gmail, like keeps like changing. So like within this case, we are going to like results like using the rack system like for that. Like since maybe thing like that too, that's very simple like for our use case.
You're still thinking about the um implementation of your agent, right? What we are talking about
Yes.
is evaluating that agent to know if it actually does what it's supposed to do. And if you remember, I mentioned one way to evaluate it is by using a golden data sets, right? Let's say company A, and your golden data set is it has a prompt that asks for the email of the company CEO, right?
Okay.
That particular data point in your golden data set may be valid today, but the CEO of that company may change by next month, and so that no longer becomes valid. So
Okay.
the point is that static benchmarks rot, particularly for many real life use cases. If it's a piece of information that is dynamic, how do you build a golden data set for it, given that the ground truth changes? Ground truth changes fairly rapidly. Or let's say you want to test for the current exchange rate between the US dollar and the British pound. What would you use as golden data set for that? Are you going to provide a static value when you know that that rate changes possibly by the second?
So maybe like something which is like dynamic.
Exactly. But anyway,
Okay.
there are ways to check that anyway. But the point is, you need to know that there is a challenge with using static. The ground
Okay.
truth shifts. It changes quite a bit in many real life use cases. That's the point here.
Okay.
All right. So we move ahead. Now, what are the tiers in agentic AI evaluation? We have three primary levels where AI agents are evaluated. We have the component level where you evaluate the LLM's function, calling. So at the component level, for example, the LLM, how does it call functions? Or LLM is a component. Whatever other component it has, it's just like unit tests. The component level is just like you doing unit tests for each component. You test each node, for example, right? That's the component level. The trajectory level is where you evaluate the agent's execution path, right? Let's assume that for this specific task, this task can be solved in 2 steps or 4 steps, but the agent takes 20 steps to solve it. I mean, that's a very inefficient a trajectory. So at the trajectory level, you evaluate the execution path of the agent. And then at the system level, you check the overall agentic AI agent system. For example, does it respect guardrails and so on? Does it respect guardrails? Well, input, whether it's input guardrails or output guardrails, whichever. But here you're testing, you're evaluating the entire agent as a system. So at the component level, you are evaluating distinct components of that agent. At the trajectory level, you're evaluating the execution parts, and at the system level, you're evaluating the overall AI agent. Any question? Okay, so we'll move ahead. Essentially, that's what we have for today. Does anybody? I guess. Well, let's see. Does anybody have any question? Okay, if there's no question, then we'll just call it a night, and we'll continue the discussion on evaluating AI agents on Thursday. Thank you very much for listening and contributing actively.
And I thank you
very
for your time. I really appreciate your time.
All right.
Yeah.
So I'll stop the recording. Good night, everyone.
Good night, sir. Good night, everyone.